Good learners, you are welcome back to our mathematics class today. In today's class, we want to proceed on matrices, but the topic called transpose of a matrix. That is the first subheading we are going to be looking at in today's class. I will advise all learners to keep tuned to the end of the class in order to see how a transpose is being done. Also, to look at how to use a matrix to solve a simultaneous equation in the easiest and possible ways. I remain Latif Ismaila Akambi, your mathematics and chemistry tutor. If you are just coming across our channels for today, kindly subscribe to my channel and click the notification bell for my subsequent content. To our usual members, I say thank you very much. I am very proud of you for sharing, liking, and commenting on our videos. The transpose of a matrix denoted as this symbol. This is a transpose. T is a main transpose. So, to transpose a matrix, so the matrix A can be transposed in the form that the row become the column. First row become first column, second row become second column, and third row becomes third column. What we have done here is transposing a matrix. Looking at these matrices, if given a matrix A, matrix B, and matrix C, we want to find the transpose of this matrix. If matrix A is 1, 2, 3, 4, then the transpose of A will be this first row become the first column. 1 and 2. 1, 2, which is a row, becomes 1, 2 as a column. Then 3, 4, which is the row, becomes 3, 4 as a column. Now, this is what we call transpose of matrix A. Now, transpose of matrix B, transpose becomes, we have just one row here. The row becomes column 6, 11. So we have transposed matrix B. Likewise, matrix C. The transpose of matrix C becomes this 0, 1, 4 becomes the column 0, 1, 4. 0, 10, 2 becomes the column 7, 3, 5, 6 becomes the column 3, 9, 16. What we have done into this matrix are what we call transpose of the matrices. Example 1. Given that matrix A equals to minus 2, 4, 1, minus 6, obtain A plus A transpose in brackets transpose. We have our A, then we need to find A transpose. After getting A transpose, we add it with matrix A. After getting our answer, we then find the transpose. That is, A transpose becomes minus 2, 4, which is the rows, become column. Minus 2, 4. 1 and minus 6 becomes the column 1 and minus 6. So this is a transpose of A. Now, let us now sum it together. Now, I want to add matrix A and transpose of A together. We have dealt with addition of matrices before. You can check the description below to look at the link in order to learn about the addition and subtraction of matrices. So let's move on. So this first column, first row, second column, which is minus 2. First row, second column, minus 2. We added up. So minus 2 plus minus 2. Minus 2 plus minus 2. In brackets here, I have minus 2 plus and minus 2. So minus 2 minus 2, I have minus 4. Fine. 4 plus 1, 5. 1 plus 4, 5. Minus 6 plus minus 6. Minus 6 plus minus 6. In brackets here, minus 6 plus and minus 6. So minus 6 minus 6, minus 12. So in this case, this is the addition of A plus A transpose. Now, finally, we now want to find A plus A transpose, then transpose. Meaning, you want to transpose this. So, this row becomes the column minus 4, 5, then 5 minus 12. So, this is the final answer to this. Example 2. Find the transpose of the matrix 3, 6, minus 5, and minus 4. Now, to find the transpose of this matrix, the row becomes the column. 3, 6 becomes 3, 6. Minus 5 becomes minus 5 here, then minus 4. So this is what? A matrix. So let's now look at how can we now use matrix to solve simultaneous equation. If you are just joining us on this channel, don't forget to subscribe to my channel and click the notification bell in order to get our subsequent content. And do not forget to also like and share this lesson. The next subheading we are going to be looking at now is solving simultaneous linear equations with two unknowns using 2 by 2 matrix. Let's proceed. Example 1. Find y if this is given. Now, we all know very well from our multiplication of matrix that this means multiplication. So you are going to multiply this. And don't forget the way we multiply matrix by matrix. This is 2 by 2 matrix, 2 rows and 2 columns. So multiply 2 by 1 matrix, 2 rows and 1 column. So let's multiply. First row we multiply first column. 5 times x, I have 5x. Then plus minus 6 times y, minus 6y. I'm done with first row. Go on to the second row. Second row, first column. 2 times x, I have 2x. Plus minus 7 times y, I have minus 7y. Then equal to 7 minus 11. Now, this means you equate row to row. 5x minus 6y is equal to 7. 2x minus 7y is equal to minus 11. Let's call this equation 1 and this equation 2. We're having a simultaneous equation now in order to get our x and y. Now, let me assume I want to eliminate y so that I can get my x. It means that in simultaneous equation, the signs here must be different. One will be positive, the other will be negative. In this case, both of them are positive. I have to make one of them positive, the other negative. Secondly, the number here, the coefficient of x, must be the same. Here, this is 5 and this is 2. Okay, let me multiply this equation 1 by 2. So that if I multiply this one by 2, it turns to 10. Let me multiply equation 2 by 5. So they both turn to 10. What about the sign? Okay, I want this first one to be negative. I will put minus here. Meaning I multiply equation 1 by minus 2 now. Minus 2 times 5x minus 10x minus 2 times minus 6y. I have plus 12y equals to minus 2 times 7 minus 14. Then 5 times 2x, 10x. 5 times minus 7 minus 35y equals to 5 times minus 11 minus 55. Next thing is to add up. Minus 10 plus 10 will give us 0. This one has gone. Then plus 12 minus 35. Taking away 12 from 35. So we are going to have minus, that is 23y. And 23y now equals to minus 14 minus 55. That is minus 69. Minus 69. And I need to get my y. I have to divide both sides by minus 23 in order to get my y. In this case, minus 23y divided by minus 23 is equals to minus 69 divided by minus 23. Minus cancel minus. 23 cancel 23. My y equals to minus cancel minus. So 23 goes in 69. So we are going to have 3. Our y is 3. I've gotten the value of my y. The next thing is to substitute the value of y into any of your equation 1 or equation 2 in order to get your x. My equation 1 is 5x minus 6y is equals to 7. Anywhere I see y, I'm going to put 3. So I have 5x minus 6 times 3 equals to 7. 5x minus 6 times 3, I have 18 equals to 7. Take minus 18 here to go and meet its family. 5x will equals to 7 plus 18. 5x will equals to 7 plus 18, we have 25. So here, to get your x, you divide both sides by 5. Then 5x divided by 5 is equals to 25 divided by 5. 5 goes in 5. We have x is out. 5 here 1, 5 here 5. So therefore, my x equals to 5. Then my y equals to 3. So that is how to solve for x and y using the matrix. Example 2. Given that this matrices equals to this matrix, then find k. The way we solve equation example 1 is still the same way we're going to solve example 2. So now, follow me. First rule, we multiply first column. 1 times minus 1. I have minus 1. 2 times 2. That is plus 2. So that is, first row we multiply first column. 1 times minus 1, I have minus 1. Then 2 times 2, I have 4. You are adding it together. Then first row we multiply second column. 1 times 1, I have 1. Plus 2 times 5, I have 10. I'm done with that. Move on to the second row. Second row we multiply first column. K times minus 1, I have minus k plus 1 times 2, I have 2. Then second row, second column, k times 1, I have k plus 1 times 5, I have 5. I'm done with that. Then equals to 3, 11, 5, and 2. Then let us sum up. Minus 1 plus 2, I have 1. 1 plus 10, 11. Minus 12 plus 12 can't be added. Leave it that way. Then k plus 5 can't be added. Equals to 3, 11, 5, 2. Now, the next step is to equate. Since you are looking for the value of k, you don't need to equate everything. What you need is, where do you have your k? You can equate minus k plus 2 to be equals to 5. That is second rule, first column, second rule, first column. Or you equate k plus 5 to be equals to 2. Now let me equate this. Minus k plus 2 is equals to 5. Take this 2 to the other side. I have minus k equals to 5 minus 2. Minus k is equals to 5 minus 2. I have what? 3. Then I need my k, not minus. So multiply through by minus 1. Therefore, minus k multiplied by minus 1 equals to 3 multiplied by minus 1. Minus times minus, I have plus k times 1, k. Then 3 times minus 1, minus 3. So in this case, that is how to get the value of k. You can as well equate this, k plus 5 to be equals to 2. In this case, plus 5 comes here, k will equals to 2 minus 5. K will equals to 2 minus 5, I have minus 3. So this is how to carry out the operation using matrices to solve simultaneous equation. If you are not yet subscribed to my channel, and you enjoy this class, kindly subscribe to the channel and hit the notification bell for our subsequent content. And do not hesitate to share, like, and leave a comment as we move on. So let's check another example. Example 3. If this matrix equals to this matrix, find x and y. Now, we want to solve this. We have to, this is a direct equation. This has been done already. It's just for us to equate. This contains x and y, x and y, x and y. So, x, this is first row, second column. That is x plus 2y is equals to first row, second column, 10. Equation 1. This one is can be found in second row, first column. That is 3x minus y equals to second row, first column, meet at 2. Equation 2. Look at this xy as well. This is second row, second column. Xy equals to second row, second column, 8. Equation 3. Now, if you look at this, for easiness, let me take equation 1 and 2 so that I can get my x and y. If you like, you can take equation 1 and 3, equation 2 and 3. It is solvable. So let me take equation 1 and 2. From these equations, I want to get the value of x. In this case, I have to eliminate y. Don't forget the rule. The signs must be different. This is positive, this is negative. Then the number, which is the coefficient before the y, must be the same. So this is 2. I want to make this one to be 2. Let me multiply this equation by 2. And this equation remains 1. If I use this one to multiply 2, it remains like that. 1 times x plus 1 times 2y equals 1 times 10, 2 times 3x, I have 6x. 2 times minus y, minus 2y. Then 2 times 2, I have 4. Then add up. This is x and 6x. This means 1. 1 plus 6, I have 7x. Plus 2 minus 2, cancelled. This cancelled out. Equals to 10 plus 4, I have 14. Then to get my x, the value of my x, I have to divide both sides by 7. So I have 7x over 7 equals to 14 over 7. 7 cancels 7. X equals to 7 here 1, 7 here 2. That is 2. We've gotten the value of x. Now, let's get the value of y by substituting the value of x into any of your equation. Let's say equation 1. Our equation 1 is x plus 2y equals to 10. Then my x here is 2 plus 2y is equals to 10. Take this 2 to the other side. 2y will equals to 10 minus 2. Then 2y is equals to 10 minus 2, I have 8. To get my y, I have to divide both sides by 2. 2y over 2 is equals to 8 over 2. 2 cancel 2. My y equals to 2 here 1, 2 here 4. So 4 over 1 gives 4. So I'm able to get the value of my x to be 2 and the value of my y to also be 4. So we've come to the end of this class. Until we meet in the next class, when we are going to be talking about determinants. Just before that class, you can attend the upcoming exercises in order to gain more understanding.